Hello, everyone. So today we're going to be talking about the concept of a unit rate. And yeah, let's begin. So a rate, as it says here, is a ratio of two quantities using different units. Now, we've already been working with ratios, but now we're going to, talk about unit rates. It says here a unit rate compares a quantity to exactly 1 unit of another quantity. And yeah, that's what we're going to be discussing with this video. So let's do an example problem. It says here you make fruit juice by adding 4 pints of water for every 2 cups of concentrate. And we're going to first find the unit rate. So 4 pints of water for every 2 cups of concentrate, that's your ratio right there, 4:2. So the ratio is written in a ratio table like this. So again, 4 pints of water for every 2 cups of concentrate. And to find the unit rate, this 2 has to be a 1. We're going to find the pints of water per 1 cup of concentrate. And we've already learned how to do this before. In order to change this to a 2, in order to change this from a 2 to a 1, we have to divide both these numbers by 2. So we go ahead and do that. This becomes 1, and then this number is going to be 4 divided by 2, which is 2. So our unit rate is 2 pints of water for every 1 cup of concentrate. So the ratio, and now for this one, we're going to swap these two now. We're going to find, we're going to write the ratio of cups of concentrate to pints of water. So the ratio of cups of concentrate to pints of water is now 2:4. Now, what's going to be the unit rate for cups of concentrate per 1 pint of water? Well, we want this 4 to be a 1. So in order to do that, we're going to divide both of these numbers by 4. 4 divided by 4 is 1. 2 divided by 4 is going to be, 2/4, which is 1/2. So our unit rate for cups of concentrate to pints of water is going to be 1/2 cups of concentrate per 1 pint of water. Moving on to the next example, it says here a piece of space junk travels 5 miles every 6 seconds. Again, this is your ratio. 5 miles every 6 seconds. And then we have to figure out how far does the space junk travel in 30 seconds. So we're going to first go ahead and write this in a ratio table. 5 miles every 6 seconds. Now, what is the unit rate? As in, what is the distance traveled every 1 second? Well, in order to figure that out, this 6 has to be a 1. So we're going to divide both of these numbers by 6. So we get that this becomes 5/6. 5 divided by 6 is 5/6. And in case you didn't know, when it comes to division problems, you can always write them as fractions. So 5 divided by 6, 5/6. Makes it pretty easy. And this becomes 1. So the distance traveled per second is going to be 5/6 of a mile per second. Now to answer this question, to figure out how far does the space junk travel 30 seconds, well, we could use this ratio, which I would probably do. You could also use the unit ratio as well. When you use the unit ratio, we're going to go from 1 to 30. So we're going to multiply both of these numbers by 30. And when you take 5/6 times 30, that is 25. So in 30 seconds, the space junk travels 25 miles in 30 seconds. How many seconds does it take the space junk to travel 2 miles? So now we're going to swap the time and distance. And so the ratio of seconds to miles is 6:5, 6 seconds every 5 miles. Now, what is the unit rate of time to distance? Meaning, how many seconds does it take to go just 1 mile? Well, we're going to divide both of these numbers by 5. So we're going to get 6/5. This is going to become 1. So our unit rate is 6/5 of a second every mile. And now to figure out how far the space junk travels in 2 miles, we're going to multiply both these numbers by 2. So this becomes 6/5 times 2, which is 12/5. And this becomes 2 miles. So the answer to this is going to be 12/5 seconds in order to travel 2 miles. What's nice about ratios, as you can see here, is you can swap the two numbers together, or swap the numbers. So from instead of 5 to 6, it's 6 to 5 over here. So cool. Okay, let's talk about the final example.
As not a teacher.
Oh, okay. All right, where was I? Okay. Yeah, so for this example, it says here you buy 2 pounds of salmon fillets at store A for $21.50, and your friend buys 3 pounds of salmon fillets at store B for $33.75. How much less would you spend for 5 pounds of salmon fillets at the store with the better deal? Okay, so let's first use a ratio table for both of these stores. So for store A, it costs us $21.50 for 2 pounds. What is the unit rate for the cost per just 1 pound of salmon? Well, to go from 2 to 1, or actually first they're writing down the cost of 3 pounds of salmon at store B. But now let's find the unit rate at store A. So what is the unit rate at store A? Well, we're going to take 2 divided by 2 to get 1. And we do the same thing here. So $21.50 divided by 2 gives us $10.75. What is the unit rate for store B? Well, we want this 3 to be a 1, so we divide both of these numbers by 3. 33.75 divided by 3 gets you 11.25. 3 divided by 3 is just 1, so at store B, it costs us $11.25 for just 1 pound of salmon, and this is the unit rate. So as we can see, store A is a little bit cheaper than store B. We have to find the cost of 5 pounds at each store. So in order to find the cost of 5 pounds at this store, we're going to take these two numbers and multiply them both by 5. So this becomes $53.75 for 5 pounds. We do the same thing over here. So what's going to be the cost at store B for 5 pounds of salmon? Well, you multiply both these numbers by 5, so we get $56.25 for 5 pounds. And we want to see how much we save when we buy 5 pounds at each store. So we subtract the two numbers together, and we find that we save $2.50, or it's $2.50 less for 5 pounds of salmon or 5 pounds of salmon fillets at store A versus store B. Yeah, that is pretty much it.